the assignment. We have gone through the assignment that okay, in few cases I asked you to enter the values of uh, marks of three subjects or information about three students. It was okay because we had only three students or three subjects to be entered. But if you are talking about say 50 students or 100 students, at that time what you are going to do? Are we going to define 100 variables, or if 100 students are appearing for six subjects, are we going to define 600 variables? Definitely not. It will be very difficult for us to manage that program with 600, 700 variables. But there is no other option but to define them because we need those many variables. So array facilitates us. Array is there in every programming language. Array facilitates us to uh, define a huge group of elements. It allows you to define 100 variables together, but all will be named with single name. All will be named with single name. Okay, like instead of having students as S1, S2, S3, S4, I am going to have um S of 10. So 10 students together. All will be named as S, but they will have a particular indexing value. That will come to that point. So there is a need of arrays when we were dealing with number of elements together. When you were dealing with number of elements together. So we'll see the formal definition of array. Array is a kind of data structure that can store fixed size sequential collection of elements of same type. Okay, so every word in this really matters. Every word in this really matters. If I am talking about a data structure, yes, it is a data structure. C is array is a data structure, means a particular organization of elements. Okay, and it's a collection of elements. It's a group of elements of same data type. Okay, a group of elements of same data type which are maintained in a sequential manner. Means one after another they will be managed. As we declare a variable, the variable is reserved, or some space of memory piece is reserved for that particular variable. If you are defining two variables, there will be two separate locations allotted for that those two variables. But in this case, at the time we are defining a group of elements, and there will be a contiguous memory block. Complete memory block will be allotted for that. Let us say that there is a group of 10 elements, then all will be there in the same block. They will not be separated from each other with a distance. Okay, they will be in a contiguous locations. We'll come to that. This word fixed size means I am going to have all the integers, then all the integers will be of size 2. I cannot have a long integer and a integer mixed together. What is the role of this fixed size, that you will be coming to know when we will be talking about the indexing part of array. So the array is used to store the collection of data, but it is often more useful to think that array is a collection of variables of same type. Okay. Yes, it permits us to store the collection of data, but this is more important, that it is collecting some data of same type, and specific element of an array is addressed by an index. Okay. I'll come to this slide. Before that, I'd like to go through this. So say this is the way we can declare an array. It says that this is an array of 50 integers together. 50 integers together. Okay. So int is the data type of the elements in that group. Array is the name of that array. It can be any variable. The way we are defining variable, we can define a variable here with all the rules and regulations which are to be followed in language C. So any name you can give. but it should follow the rules and regulations. And in bracket we are mentioning size, array size. So this is a group of 50 integers. This is a group of 10 characters, which is named as ch. There is a group of 10 characters. There is a group of 5 integers. This is a group of 15 characters. This is a group of 4 floats. Okay, so in what will happen here in this case, what will happen, let us say that for this there will be, as soon as it is declared, no matter it holds some value or not, as soon as it is declared, there will be a contiguous memory block reserved for this one, particularly for this particular group of elements, where we are going to have 50 elements together. We are going to have 50 elements together, starting with the, this will be the first element, this will be the 50th element. This will be the 50th element. Okay? So this continuous memory block will be allocated for that. So what I can see is there are 50 elements, 50 integer elements. Each integer is taking 2 bytes. So this block will be of 100 bytes. This block will be of 100 bytes. Okay. So as soon as you declare an array, you are going to get reserved with 100 bytes of memory. So, and out of which first 2 will be for the first element and last 2 will be for the last element. Okay. Similarly, as soon as I am talking about character ch10, there will be a block of 10 characters reserved. Okay, this will be the first one, this will be the 10th one, but size of character is, as size of character is 1, we are going to reserve 10 bytes. Okay, 1 for each character, we are going to reserve 10 bytes. So this way the reservation is done. Likewise, as soon as I declare, say, int a, no matter you initialize it or not, no matter it holds some value or not, it is going to be declared, it is going to be reserved with some space in memory of 2 bytes, and that space will be named as a. In this case, this whole space will be named as array. This whole space will be named as array. This whole space will be named as ch. Okay. This whole space will be named as ch. So are you understanding me? Whatever I am trying to say. Now I am illustrating one thing here. I am illustrating this array. I am illustrating this array. Are you understanding, or am I going very fast? Please prompt. Am I going very fast, or you are understanding the things very properly? Yes.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So coming back to that, now I'll just erase it so that there will be no much confusion. Now I am going to detail out this, or this is the way I can declare an array. This is the way I can initialize an array. It can be done later also, but if I know the values in advance, I can do this way. So here, these are the 5 elements which will be the part of this array mark. These are the elements which will be the part of this array name. These are the elements which are the part of this array cost. Okay, so I can initialize them also well in advance as soon as I declare. So let us detail out this. The detailed figure for this mark is presented here. See what is happening here. The first element is stored here. Immediately next will be the second element. Immediately next will be the third, fourth, and fifth element. Okay, but observe a very careful thing, that this is indexing. This is indexing. So first element is actually said as mark of 0. So the indexing of array, be very clear about it. The indexing of array starts from 0, not from 1. So as we have 5 elements, the 5 elements will be 0th element, first element, second element, third element, and fourth element. So total 5 elements. But indexing will be varying starting from 0. So let us say that we have 5 elements, then indexing will be from 0 to 4. We have 10 elements, it will be from 0 to 9. We have 100 elements, it will be from 0 to 99. So if we have n elements, it will be from 0 to n minus 1. These things you need to keep in mind. Okay? So always you keep this in mind. Now mark 0, it is written in this way. Mark 1, it is written in this way. So this is the name of array and this is the index of that element. Every element can be separately addressed. Even though they appear in a group, all the elements have their own identity and they can be separately operated on. Simply as see here, mark of 3 is equal to 17. So what I can do is simply mark of 3 I can write as 20. Directly this element is going to change to 20. This element will be directly changing to 20. Uh, Mark 3 will directly be changing to 20. This element will be changing to 20. So I can operate on any element directly. Even in this case, let us say that I'm what I can do is, for example, I can say that marks 5 is equal to uh, marks 3 plus 10. This is also possible. This is also possible. It will simply change this. It will change this, add 10 to 17 and will make it 27 simply. Okay. So these vary. So the marks, not marks 5, it should be marks 4. So marks 4 can be changed to marks 3 plus 10. So these are just very simple variables, just the way we are doing it for any variable of a plus b is equal to c. We can operate on any of the variables of your array. Okay. So these are separate variables, but they are only grouped together. They are addressed with the same element. So I hope I made the point clear. We'll go for one more thing out here. So here also you can see in this there are elements. There are total 9 elements in this array. So index is varying from 0 to 8. So total 9 variables. So hence it is n minus 1. N is 9. So my highest index will be n minus 1. Highest index will be pointing to the last element. Lowest index will be pointing to the first element. So array length is 9. First index is 0 and last index is 8. This is the way we do. Now, what second thing we need to keep in mind is, as I said, as soon as I declare this variable or array, a memory block will be allocated to it. So that this is named as mark. This is named as mark. Okay. So this whole block is now known as mark. This whole block is known as mark. But this block is particularly named with addressed with a particular thing called as base address. Okay. That means as soon as you declare an array, a group of elements will be, a group of memory locations will be allotted, and its first address will be given an address which will be called as base address of that array. Let us say that the base address of that array is 1000. Okay, let us say that base address of this array is 1000. That means that a group of memory starting from location 1000. Group of memories starting from location 1000. Okay. Now listen this very carefully. This is very important part. But This 1000 is also the address of its first element. Address of its first element. Okay. How to get the address of second element? Second element. So first element is going to accommodate two memory locations. So 1000 plus 1001. So next location will be, next element will be stored at 1002, which is going to consume 1002 plus 1003. So what will be the address of this element? As it is a contiguous memory location, each number is taking 2 bytes. This will be your 1004. Okay. Similarly, this will be your 1006. And this will be your 1008. Now, what peculiar thing you can observe in this is, uh, if I am talking about the second element, it will be a jump of 2 integer bytes, this 4 bytes, okay, from the initial location. So it's very simple. If I'm talking about, let us say that if I'm talking about M0, it will be base address plus 0 bytes. Base address plus 0 bytes. Okay. So if I'm taking base address is, what is base address? It is 1000 plus 0 bytes. The address of first element is 1000. This way we go for. When I talk about M of 2, it will be base address plus 2 integer bytes. 2 integer bytes means 4. So it will be 1004. You can see here. This is the address of. So how I can generalize this statement? How I can generalize? I'll just wipe out this. How I can generalize this statement as M of I will be equal to base address plus I into size of element, right? I can, so whatever may be the element, let us say that it is, we'll just check out whether it works or not. If I'm talking about M of 4, it will be base address 1000 plus 4 into integer bytes 2. So it will be 1000 plus 8. It will be 1000. So is it working? Yes, this location was at 1008. So this way you need to, what is this called as? This is called as, very particularly, this is called as relative addressing. You remember this word. This is called as relative addressing. Relative addressing means we are known with only one address, that is the base address of the array, and we are locating all the other locations, all the other variables relative to this base address. Relative to this base address. That is why it is called as relative addressing. So I hope I am clear with this. Second thing which you need to keep in mind is, say here array is defined by as name and size 15, but I am consuming only 8 bytes of it. Rest of the 7 bytes are wasted, because as soon as you declare this, that whole block is going to be reserved. And no matter you are storing there 1 character or 10 characters, it will be 15 allocated spaces. So in this case, 7 bytes are wasted. So be very careful while declaring an array. Don't declare the array oversized. Unless if you want to store 60 variables, okay, you can go for 62 or 63 or at the max 65. But if you are storing 60 elements and you are declaring array of 100 elements, other 40 spaces are wasted. If it is a character, 40 memory locations, 40 bytes are wasted. If it is a float, actually 160 bytes are wasted. So do not waste the memory. It is a bad programming practice. So this is the way an array is defined. And one more thing which I like to tell you is the character array are called as strings, which has a very separate base for in C. These are very separately treated. So, am I clear with this? Any doubt till this point if you wish to ask? Any doubt till this point? You can put in the chat box or you can ask putting your mic on. Fine. No doubts? Is the things clear? Are all things clear?
Yes, sir.
सर एरे के वेरिएबल को इंक्रीमेंट कर सकते हैं
Array के
सर जो एरे का वेरिएबल है उसको इंक्रीमेंट कर सकते हैं
हाँ, will be coming. Yes, you can do it. We'll be coming to that example. But till this point, if it is not clear. So ठीक है, मैं समझूं कि ये सब clear हो गया. Because whatever quiz you are going to appear for, it is going to have these array basic concepts also in that. That's why I'm covering this part. अब हम लोग कुछ चीजों पे ध्यान देते हैं. Now, as I said you, this array elements can be treated separately. These array elements can be treated separately. As they can be treated separately, that means they can be entered separately, they can be printed separately, they can be manipulated separately. Okay, but only thing is we are not to some extent permitted to delete some element because it is permitted. It's not that it is not permitted, but I cannot just simply delete 8 from this place and try to remove this element. No, if I am removing this element, this has to be shifted because array is a basic definition is it is a contiguous. It will be placed at a contiguous memory locations. So only thing is what if an array is there, I cannot have the elements at the starting as blank. I can leave the elements at the ending at blank. I cannot have any elements at the beginning as blank or any element in between as blank. I can have latter elements as blank. Okay. So if the array is like in this case, array is of 15 bytes and only 8 of them are used, then first 8 will be used, the rest 7 will be left empty. Okay. So it is not that okay, first 7 will be left empty and then next 8 will be accommodated. No, it doesn't happen. Right. So that care only we need to take while dealing with arrays. So few things which I want to repeat again, that arrays have 0 as first index, not as 1. So every array is going to start as mark 0 or array 0 or ch0, whereas this is your array name and this is your index. This index is also called as subscript. This index is also called as subscript variable. Okay, this is a subscript of that array. So that also you remember, subscript of this array or array. Index of that array. So that's what I said. If size of array is n, then highest index will be or last index will be n minus 1. And if mark 0 is at 2120 memory location, then at every second location you are going to get the next element. So go on adding 2 because size of integer is 2. If you are taking a float array, go on adding 4. Okay. So array is a group of similar elements, and that's why in the very first slide I mentioned that fixed size word. I said that we'll come to this later. You have to be of fixed size, then only this relative addressing is possible. in the contiguous memory location. If you are not of fixed size, it will not be possible. And that's why we be very particular that it will be a fixed size sequential collection of elements. That's why I'm coming back to that particular point. So the array can be a group of elements, array can be a group of integers, characters, float. Not only that, it can be a collection of structures, it can be a collection of arrays also. There can be array of array. There are multidimensional array. That we'll come to that discussion later. But array is a group of similar elements. Those elements can be integer, float, character, long, double. Uh, it can be a structure, it can be a union, it can be the array itself. Okay, that care we need to take. So all things are there. So now let us try once. Okay. As I said, they are separate elements. That's why they can be separately entered or separately printed also. So in this way, I can enter the array. In this way, I can enter the array. Uh, Whereas this element is separately entered as mark 2. This will be the third element of an array with index 2. Okay, so that can be directly entered the way we are entering a, b, c, d, any damn variable. This can be entered in the similar way, or it can be entered in this way also. I can have a variable as a subscript. I can have a variable as a subscript, but that will lead to a constant. That will lead to a constant. That is for sure. Similarly, I can print. Only difference in print and scan is there is missing ampersand. Ampersand will not be used with printf. So the first element, the third element, and your it can be also subscripted in a with the expression. So this way we can scan or we can uh, print the elements in array. So we'll go for two small programs, and so first we'll take a small program of entering 5 elements and printing them. Did not really go into details. So we are declaring one array called as values, which will be of size 5. So indexing will be from 0 to 4. We'll print a message, and then for repeating the input operation, we are making use of for loop. Okay, so this for loop is used in this way, very simple. With I equal to 0, we'll start with I equal to 0, and with 0, I am going to enter the value first. So value I is 0, hence this will become value of 0. Value of 0 will be entered. Let us say that we are entering 10. Okay. After that, it will go back to this location. I will be changed to 1. It is still lesser than 5. We are going to enter next element. Again, it will go back. It is going to enter 30. This is going to enter 40. Then we are going to enter 50. Likewise, after 50, I will become 5. The condition will be untrue and it will come back. So here, array can be entered through a repetitive or loop statement. It is also possible for us to use a while loop here. Okay, so whatever you wish for, but preferably for will be used in case of arrays. In a similar fashion, with the similar for loop, I can print all the elements from that. So this is a very simple program of accessing an array. So this will be a kind of output you are going to get. Okay, as we don't have /n here, it is going to take the input value here, and after each input you are pressing enter and giving the input. It's not necessary, you can go for the input in this way also. By separating them in with space, it is possible for us to give the input. Okay. So this is possible. So either way is possible. And here also, as we don't have a /n symbol here, it is printed in the same line. Later we are followed with a /n symbol. That's why all these elements are printed in the next line. There is a simple statement in which we can add the elements in the array. We'll go for another program, which will be a program to find the average of n numbers using arrays. This is for demonstrating how arrays can be used as variables. Array elements can be used as separate variables. In this case, we are declaring four variables where marks 10, I, n, sum is equal to 0 and average. Sum is initialized to 0 because we are going to add every element into that, and that total sum will be divided by total number of elements, which will give us the average. This array is capable of storing 10 elements, but still with n we are going to enter the number of elements with which we are going to do. So enter the number of elements, it will be 10. Sorry, it will be n. Let us say that n we are taking as 5. So only 5 elements from this array will be used, the rest 5 will be left blank. Fine. Now for entering the array, we can have a for loop which will vary from 0 to n. N is the value which is the maximum number of elements the array is storing currently. It can store 10, it is currently storing 5. See here, what we are doing with I plus 1, it is simply a message enter number 1. First element is at 0 index. That's why I is at 0 and I am just adding a subscript of 1. So which will print it as 1. But element entered will be markup 0. Okay. So it is going to print as enter number 1 and we are going to initiate a number. And as soon as you initiate that number, you add it in the sum. This will be equal to sum is equal to sum plus marks of I. So as soon as I say, let us say that I enter 10 here. So sum was 0, it will become sum become 10. Sum becomes 10. Okay. So this way you are operating on. Then again you go back with I is equal to 1. You come back. Let us say that we have entered 20. Now this 20 will be added to the new sum and will make it 30. Similarly, you are going to add all the 5 elements. Okay. Once you get the final sum of it, it can be divided by number of elements and you get the average of it. The average can be separated. This is the way you can. So this will be a kind of output. We are going to enter n, then 45, 35, 38, 31 and 49. 5 elements are entered. Here you can see what I said is I plus 1 is returning 1, 2, 3, 4, 5. It's just a printable character. It's not a number. And then average is found. So this is the way we are dealing with arrays. These are very basic discussions regarding arrays, and we'll discuss it further for more complications. Now you have a homework. You have a homework. As in the discussion, I said that is the promise. Other things clear? Is the topic clear? This prompt in the chat box.
Yes, sir.
All, because only few people are just prompting and rest are, I find, very inactive. So many of you are saying that it is clear. So there is a work for you. You will study strings today and tomorrow. Okay, what? You will study strings. Strings means character array. You are going to study okay. So string is a character array, but in C particularly, it is supporting this as string because many a times we don't use a single character. We need to use a group of characters, and every time dealing with single character for that name is becoming difficult. That's why scanning of it or entering or printing is handled separately with a separate header file. So I expect you that you will study strings for next 2 days, today and tomorrow, and the activity day after will be very much dependent on string. Okay, so strings पे ही ये activity dependent रहेगी अगली आपकी. So strings आप लोगों ने सभी ने पढ़ना है. ठीक है. So now this is all about from my side. Any doubts if you wish to ask, you can ask now only. Otherwise, we'll proceed for further activity. So no doubts. Shall I tell you the activity? Fine. Uh, Today's activity will be quiz. That quiz will be posted on Canvas. That quiz is posted on Canvas. You all have submitted the assignment. Today the reviews will be allotted to you. But along with that, now if you after 10 minutes after the break, you just see a quiz will appear there. That quiz contains 30 questions, and a time given for that is 90 minutes. But most of the questions are of type find the output, and all are based on the topics which we covered till date in this subject. Okay, so you solve this quiz, but it's my very honest request to all you people that please don't solve the quiz by just pasting that operation in a C compiler, compiling that program and getting the output. Okay, then definitely you are going to get a correct answer every time. So there is a question, there are 4 options given. Out of that option, one will be the correct output. You are supposed to find out. But my sincere request is to do it manually. Do not use any online compiler or a compiler installed at your machine to execute that code and get the output. You only do it manually. That's why for 30 questions, I'm giving you 90 minutes. This is a self-assessment exercise. You'll definitely enjoy, and you'll be getting the score of that. But my sincere request is to don't cheat, because I'm not there to watch you. No one is there to watch you. It's you only who is watching yourself. Don't cheat yourselves. Find out the answers. For me, the lower scorer will be preferable students than the higher scorers, because for higher scorers probably I think that they know C, and I'll concentrate on the people who are scoring lesser marks. So if you are just compiling that code on a compiler and finding out the output and giving the correct answer, you may score fully, but you will be unable to test your understanding of C. So please do not do that. Okay. So we'll break for 10 minutes. At 11 o'clock, the quiz will be available in your Canvas account. Go there, sign in, and try solving the quiz. Okay, solve it manually, and I'm repeating again. Any doubt? I'm available on WhatsApp. You can ask me the questions. Please don't ask me the questions in the quiz. Whatever questions or doubts you have, that you can ask, but you don't ask me the answer for it. Because yesterday it happened. Few people asked me the answer directly. So ये नहीं आ रहा है तो इसका कैसे करेंगे? No, it's your job to find out those answers. It's your judgments to give that answer. So I'm available on the WhatsApp. You can drop me the message, and after 10 minutes you can start solving the quiz. Okay, so we'll stop here for today's lecture.